As the human race faces the arrival of a new millennia, there is one shadow on the world horizon that increasingly casts questions about survival, growth, and the quality of life everywhere. The supply of fresh water, every nation's first resource, is that cause for concern. In many places on the planet, it's already an outright dilemma. Surface water supplies are being overutilized, polluted, or just drying up. As water scarcity spreads, the cost of developing new water supplies by traditional methods are skyrocketing. Now, new technologies are being effectively and economically applied to previously ignored sources of groundwater. Today, BCI Genetics, an innovative firm specializing in groundwater exploration, has joined with some of the world's leading experts on exploration technology to develop new methods to find and utilize these resources. Dr. Lauren Everett, a specialist in the field of remote sensing, describes some advantages of these new technologies.
Satellites that are going up now are multi-probe satellites that have resolution that allows us to look at features that are very, very small, in fact getting down to looking at features that are less than a yard in diameter. And so what we're looking at now is a distribution of sensors that one can interpret to give further kinds of information, such as the distribution of temperature at the land surface, the distribution of vegetation at the land surface, the distribution of soil moisture at the land surface, all of which can point to where the recharge areas are. And this is a capability that we simply did not have 5 to 7 years ago.
Access to this new type of remote sensing technology is now allowing a special team of scientists at BCI Genetics to successfully locate new water supplies around the world. Steve Bachman, a PhD geologist, explains some of the concepts behind BCI's exciting work.
Our program uses, in a systematic manner, a series of high technology approaches using everything from high altitude and satellite photography through geophysical techniques and sophisticated structural analysis to look at the rocks in the field. One of the things that our exploration program leads us to is areas that are not the typical places to look for water. For instance, as you can see in the background here, in this particular area, we've been led to this through our analysis into terrain that would not be what most people would consider to be typical water-bearing areas. But our research has shown that this is one of the best places to look for water within the foothills here, and we let our research then drive our notions of where to look for water.
Trademarked as the MESA program, Mineral Exploration Systems Analysis, this systematic technique of research and exploration has led to the discovery of unprecedented quantities of water on several continents, including Africa. Designer of the Space Shuttle's large format camera system, Dr. Farouk El-Baz, director of the Center for Remote Sensing at Boston University, describes the importance of remote sensing mapping.
Therefore, we need to collect information about it. To collect that information by conventional means will take a great deal of time and effort and money. The space platform provides us, or provide us in general, with a whole new tool to look at the arid lands and study them.
Although these new technologies are allowing BCI's team to locate new water, strong emphasis is being placed on the thorough understanding of the entire resource. Bob Bisson, chairman of the board, explains.
There is no such thing as a simple approach to groundwater detection or exploration. And the discovery of a point on the earth where there is water is almost counterproductive in the modern world, where we need to know the sources, the pathways of the resources we use, or we run into trouble in planning ahead in the use of that resource.
With this philosophy, BCI has developed a program in which the total water cycle is mapped and studied prior to the development.
One of the things that's not obvious as we stand here looking at these rocks is that there's a significant amount of recharge that occurs within the bedrock. We have made calculations in the Santa Barbara area that there's more recharge going on within these rocks than there is in the alluvial basins from runoff.
Still, Some are concerned that BCI's technique may actually be the mining of water.
Typically, when one looks at a recharge area associated with the kind of studies that BCI is doing, they're looking at a substantial distance between the recharge area and the withdrawal area, and does not speak to mining of water, in that with a recharge area one has a substantial capacity to hold water in the fractures, and so it's a continuing source as opposed to a mining of water operation.
As a result of research into this complex hydrologic cycle, BCI has discovered one additional benefit associated with the use of bedrock groundwater to augment surface water supplies.
As we've conducted our research on recharge of bedrock, we've found that the bedrock is more drought resistant than the alluvial basin. For instance, the water that we can produce out of this bedrock today is water that was recharged prior to the drought during times of heavy rain. So the offset cycle we have here gives us some drought protection if we put this into a program in which some water comes from the alluvial basins and some water comes from the bedrock.
A natural concern with the development of new water sources is its potential cost. Severe drought conditions forced the city of Santa Barbara to face a number of expensive options in solving its water problems. Then it was presented with BCI's groundwater development program. Jim Doherty, president of BCI West, describes.
BCI, however, knew that there was another solution, and that solution really was bedrock and new resources which they had not yet developed, groundwater resources. And so we came to them with a program that allowed them not to take on any of the financial risk. We had short time frames in which we were going to provide the water, and we could provide the water quickly and efficiently. And during the period of time that they were using this on the short term, they would have a chance to evaluate and come to determination as to the long-term potential use of this water. We believe that that water will be used on the long term, that it will have a very beneficial use as a conjunctive use source, that using it conjunctively with the groundwater, with other sources that they have at their disposal, they will create a management program to help manage all of their water resources and still keep it within their control, so that they do not have to commit to very expensive, environmentally sensitive kinds of solutions such as desal, such as state water projects, etc.
The BCI team can also focus its non-conventional approach on accessing sources that have confounded others to immediately satisfy client needs.
What makes BCI very unique is that we are problem solvers. We tend to look at the problems that they're dealing with relative to their own supplies and attempt to find ways to come up with solutions and to give them the kind of solution that's most appropriate for their particular situation.
One problem recently solved by BCI involved an area that once represented one of Santa Barbara's major water supplies.
We're above Gibraltar Reservoir and Gibraltar Dam. As we can see in the distance, the reservoir is dry and has been for about 3 months. This used to be one of the primary water sources for the city of Santa Barbara. Before the dam was built, the sinuous river was full of cobbles and gravel and sand. However, after the dam was built, silt began to back up behind the dam, and now the reservoir is more than half filled with silt. It was common knowledge that these silts were full of water, but the question was, how do you get the water out of the silts? BCI's approach was to extract water from these old stream gravels beneath the silts. We started this process by doing a series of geophysical techniques to find these old stream gravels. Because this technique had never been used before, BCI assumed the risk for the operation. We have now drilled 3 wells, and they are extremely successful. We expect from those 3 wells to be producing as much as 1,100 acre-feet of water for the city of Santa Barbara over the next year.
In a world of shrinking water supplies and rising water costs, BCI Genetics is finding and developing new and affordable sources of this essential resource. Combining the latest in space imagery and geophysical methods with a new understanding of fractured geology, BCI continues to site new wells and unexpected locations around the globe.